Hi, Reggie here, and today let's predict the image formed through a convex lens. Now first, let us identify the parts of the diagram below. Now here we have the illustration of the convex lens in the middle of the diagram, and then we have marked the areas of F or the focus and the 2F, which is twice the distance from the optical center, which is the middle part of the lens. Now on the other side, we have the focus prime and the 2F prime. Now, how do you determine in real life the distance between the lens, which is the optical center, and the focus? You can have any object which is well lit from a very far place and then face the lens and allow the image to project to a screen. The distance in which the screen is placed where the object, which is very far, is projected is the distance of the focus to the optical center. And of course, by just multiplying the focus to 2, you will have your 2F. Now, without further ado, let us continue and learn about the concept behind predicting the image through a lens. Okay, first, if we're talking about a convex lens, we have a different set of rules compared to a concave. If the incident ray is directed or aligned with the focus, it will be refracted or it will bend. The light will bend parallel with the principal axis. And if it is parallel with the principal axis, it will then be refracted towards the focus prime. And if it passes through the optical center, the light ray will not be refracted. Okay? Now with that, let us start the diagram. Okay, let's follow the first one. It says that it passes the focus, just like that. Okay, what will happen? It will be parallel with the principal axis, just like so. Okay, and then what happens next if it is parallel with the principal axis? Okay, just like that, it will be refracted towards the focus prime, as so. And finally, if it is going to pass through the optical center, it will not be refracted. Now, as you could see here, all the refracted rays have intersected at the same point. So what does it mean? It means that the point in which the rays originated is where the image formed on the other side, which is the tip of the arrow. We could illustrate it like this. So how do we interpret the image formed? First, it is inverted or upside down. And then you will notice that it is relatively larger than the actual object. So let's place larger. And finally, we could say that it is a real image. Now you might wonder, in mirrors, it is determined as a real image if the image is projected on the front. However, if we're talking about lenses, if it is projected through the lens, it is a real image. Now, let's have another example. Okay? We have an object placed exactly at the 2F of the lens. So, let us begin. Again, same rules. Okay, parallel with the principal axis will result to a refracted ray which will pass through the focus prime, just like that. Next is we have a line that passes through the focus will then be refracted parallel with the principal axis, just like this. And finally, if the line passes through the optical center, okay, it will not be refracted. Okay, So as you could see, it has intersected at the same point. And let us draw the representation of the image, which is the tip of the arrow. Okay, notice that the location and the size of the object retained itself, or the size of the image has been retained. So we could say that if the object is placed exactly at the 2F, the image will be inverted or upside down, and it will be the same size, and finally it is a real image. Okay, next let's have our third and last example. What if we are to place the object exactly between the optical center of the lens and the focus of the lens, just like in the illustration? So let us try and predict that. First, the same rules apply. If it is parallel with the principal axis, just like that, it will then be again refracted towards or through the focus prime, just like that. And the next is, if it passes through the optical center, it will not be refracted, just like that one. Okay, and finally it says that if it is aligned with the focus. Now you notice that the focus is on the other side or opposite of the lens. So how do we do that? What I like to do there is to trace the line from the focus through the tip in which the light is originating. So it is now aligned with the focus. So in that case, we can now proceed to the next part, which is to determine, what will happen next. It says that it will be parallel with the principal axis, just like here. Okay. Now notice that all the refracted rays, even if you extend them, will not intersect. So what happens, or what should we do if that happens? Similar to mirrors, if the reflected rays are away or moving away from each other, you're going to draw a line opposite of the reflected ray. So same with the refracted ray. So we're going to call it virtual rays as well. So we're going to represent it with a broken line. So let's start with the one which is parallel with the principal axis. Okay, and then let's proceed to the one which is passing through the focus prime. Okay, and finally, let us have the opposite of the optical center. Then notice that they intersected at the same point again. So if we are going to illustrate the object, it will be located on that point as well. Okay, it's a little bit too thick. Okay. Now, notice the changes in the image. Okay, so here the original object is much smaller compared to the image when it is viewed on the other side of the lens. So it means that the object is larger than the actual object when viewed from the other side. Now, next is the object is still upright. Okay, so it did not change its orientation. And finally, since it is made because of the intersection of virtual rays, we call it a virtual image. Okay? So that's why when you look through a magnifying glass, if the object is near the lens, you will see it as much larger than the usual. And if you look at objects that are farther through a magnifying glass, it will appear inverted. So that's the concept behind that. So that will be all, and goodbye for now. Don't forget to like and subscribe. See ya!